Hey everybody, this is Larry. This is me going with bi-weekly contest 172, Q4, last remaining integer after alternating deletion operations. Hit the like button, subscribe button, join me on Discord. Let me know what you think about this one. I think there are a couple of ways to do it. Honestly, I did look at some solutions after I did it. And I think the way that they did it is much cleaner than I did. But I think the idea is still the same. It's just that I kind of probably made things a little bit more complicated, but that's okay. The idea behind this one is just really recursion. And I'm going to bring up, I don't know why my computer's being wonky, but yeah, let me bring up my drawing thing right now. Hang on. But the idea here is just recursion, right? And there probably, there are a lot of similar ways to do it. And the way that I did it is still kind of true, and I'll show you my way in a second, but I'm going to explain the way that most people did it, and which makes more sense after I, but when you're in a contest and when you're like, not feeling 100%, these things happen. As long as you solve it, it's fine, right? And even if you don't solve it, it's fine, right? But the idea is that, okay, you start with right? Let's just say 80, right? And then the first operation is 6, 7, 8, you cross out all the other numbers, right? Well, what do you left with? Left with 1, 3, 5, 7, 79, right? Okay. So then now, the recursion is just, okay, you went from f of 80 to f of 40, right? But what does that mean, right? That means that the number that we get from f of 40, we basically remap all these numbers from 1 to 40, right? Oops. And that's it. And then whatever number that we get from here, we just remap it to these numbers, right? Or maybe here to here, really, right? So that means that, for example, if for whatever reason, I don't think this is actually a thing in the thing, but if you get like a 4 here, that means from f of 40, you get, that means it's equivalent to a 7 here, right? And so forth. And that's really the core idea about this. I mean, there is something about going left and right. So maybe in this case, actually, you have something like this, and maybe you can, there are two ways to think about this. You can either, add a parameter that goes left to right or right to left, or you can just remap it as part of that, right? Meaning that, maybe 1 in this case map to 79, 2 map to 77, and so forth, and then 40 will map to 1. I mean, the details, you can figure out. It doesn't, there are many ways to do it. I urge you to play around with a lot of them. But that's kind of the general idea behind this problem. The way that I did it is kind of the same idea, but not quite the same way. The way that I did it is actually I did it with 2 passes, because one goes left, one goes right. So that means that if you have 100, instead of going to f of 50, I go to f of 25. Basically, instead of going to, I go 1 pass to the left, 1 pass to the right, and then that's basically it. And the way that I did it is very similar to other people's, but it's just that I do 2 passes at a time, which maybe is not ideal, but it's fine. It got working. By the way, I did also write like a brute force algorithm to kind of see if I could figure out a pattern. But this one actually, I probably should not need it to do this, and I probably should have seen this idea much earlier, but I was just kind of struggling a little bit, right? But anyway, the way that I did it is that, okay, with 1 pass, you have this number of numbers remaining. With 2 pass, you have this number of numbers remaining. If the original number is even, then, you subtract 1 for whatever reason. And basically on the backwards pass, there are only 2 ways to kind of go from, right? This is 0 index, that's why it's 0, 2, but it actually should be 1, 3, 5, 7, 9. Oh, sorry. After 2 passes, you either get 1, 5, 9, 13, ... or 3, 7, 11, 15, ... right? So there are only 2 possibilities, right? after the first one, right? After the 2 passes, and that's why and yeah, and if the last number, if for example, if the last number after you get rid of the even numbers, which is why I have it like this, it's not the cleanest way to do it, but that's the way that I did it. Yeah, if you get a 13, for example, then we know that it starts at 0. If you get a 15, then you start at 3. And of course, this is is 0 index, so I do 0 and 2, right? And I plus 1 at the end. But yeah, and then we do recursion to get the R of the, so we get the answer for the smaller recursion, and then I just wrote the starting thing plus R times 4, because this is the this is the pattern, right? Because there can only be 2 patterns after that, and that's basically it. And for less than 4, it could only be 1, 1, and 3, 3. I mean, you could probably write this in a cleaner way, but I was like, I don't want to think about it. This is going to be correct as a base case, so yeah. And that part I did kind of get from the brute force way, though. You could probably work. I mean, I work it out. It's 4 numbers. We could work it out mentally anyway. But I kind of saw the pattern. I saw that was maybe sufficient. Yeah. So what's the complexity here, right? Well, it's going to be just log x, right? Or log this n, which is linear in the number of bits, which is the linear in the input size. And that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you can watch me solve a live in a contest next. Very dumb mistakes. Still feeling a little down, I guess. Alright, given the intro and you're writing. So if it's 1, then 1. If it's 2, then it's also 1. If it's 3, then it is 3. So it is 1, 1, 3, 3. It's 0 index, but that's fine. And then now. This is actually a little bit tricky on the other side, right? Because then now you start with the. Also, this is wrong. This should be 1. And then now you start with so that's the first number, so you want this as the last number. Something like that. Just to be consistent, I guess I'll do +1. Oh yeah, it doesn't work for 0, but that's fine for the rest of them. Okay, so 1133, 1133, 999. I figured that it would look something like this. The 33 is actually surprising. Maybe? It's some binary number thing. I mean, this is a new power of 2, so 9 gets introduced. And the next one is after 16. 16 does not get introduced. Only 32. But this is so annoying. 3 is 1, 2, 3, 2, 4 is 2, 2, 2, same thing. Okay, so with odd is with even, that's going to be the same thing as the previous number. Okay, which makes sense because it just, the first operation just takes out the extra even number anyway. Okay. And then what? I don't know that I see anything obvious. So this is 1, 1. So I think it's just like a pattern that grows or something. Like a recursive thing. Like it probably repeats. This, like this repeats. It hits 8, and then now it's 8 plus these. And then that repeats. Right, and then that, in a way. And then now it is 32 plus all these things. So I mean, I guess I see the pattern, but I see a pattern. I don't know if it's, or I have enough to formulate it. Like every other power of 2, it's going to start with this thing again. Good thing about the numbers that you eliminated, the even numbers don't matter because they, from the first one it gets eliminated, and then the second one, if even numbers don't matter, then the first digit don't matter, right? Or first least significant bit don't matter, because we're just left with the last one. So then now we have 0 and 1, and we remove 0 in both of these, remove 1 in these. What's 5? 2, 3, 4, 5, 2, 2, 2, 2, 4, 3, 1. Is it 2, 4? Is this right? We remove 2, 4, and then we remove 3. Oh, I see, because you move 3 and then 1 removes the 5. Okay, but with 5, maybe I need to draw it out a little bit somewhere. So with 5, okay. Something like this, right? Again, the even numbers don't matter, so we could just say the first digits don't matter. So then now we remove this, and then we remove this, right? Where if I have this, then we remove this. How did I figure out how? Is it a recursive thing? Well, okay, so after 2 moves, it's recursive. Kind of. I mean, yes, but you have to map all the numbers. This is why this looks like this. Now starting from 9. And even 9 is just 1 plus 8, right? So then this, is it all just 1, 3? So these are all just 1 plus 3 plus some no, I mean, well, that's because this is not this is 11 plus 32 and 9 plus 32, so it's, so that's how it becomes recursive. This is a problem that requires a lot of patience. But I guess it is just the same, right? Because, okay, so let's say we have at least, I mean, I think it's just recursive. How do I write it precisely? So then now, okay, so let's say we have, so every 2 passes, what are we left with? With n over 2 for the first pass, and then we subtract another n over 4. So then we now goes from n to n over 4, roughly. Not, and you have to be really precise about it, but that's okay, right? Well, what does that look like? No even numbers on the first one, but recursively, that's just another bit. So in theory, we should just, it's just about spotting the location and then do a recursion and then so forth. How do I write that precisely? Oh guys, So then now, maybe we just hard code the smaller 3 numbers. Okay. So let's say n is equal to 100, right? So we know that we get rid of the even numbers, and then 25. So then now we get the answer for 25. Okay, but how does that work? So how do we remap it, right? So now we have 25 numbers left. Or do I do it the other way and just going from no Well, okay, let's look at it, right? So you have 100, you get rid of all the even numbers, so you have 1, 3, 5, 7, 9, 11, dot, 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 all the way to 99. You remove every other one. I don't know if it goes which way, but so it looks something like this, right? Then let's say you have 25 numbers that look like this. So then now, I mean, it's doable. It's just annoying, right? Because then now, we try to figure out so we get the answer for the recursion, and then we have to figure out how this is. And okay, so we have to figure out whether the odd number starts with 1 or starts with 3, and that's why, okay, so it's 3 when it starts with, when it ends at, okay, that's why this 3 and 1 comes up all the time. I mean, and 9/11s are building off that, because if you remove the first number, so then okay, so then let's keep it with 1. Okay, so then yeah, And you have to be precise, right? So okay, so 100 is a number that's perfectly whatever. So okay, so we do x. Okay, so then we lose half, but half is round down. So we keep half round up, right? So let's just say 1 for 1 pass, and then 2 also round up, right? Okay, that seems fair. And then we just go f of 2. Oh no, this is that 1. Okay, but we have to determine whether it starts with a 1 or a 3, right? It starts with a 1 if okay, it starts with a 1 if we don't delete the 1, obviously. So it'll be 1 5 9 ... So that means that if okay, let's see. So you have 1 5 9 13 maybe, right? Then you have 3 7. So there are only 2 sequences that it can go, and one, whatever 1 is left. No, I mean whatever x, right? So x we divide it by 2. So then whatever's left, so x. So if x is okay, so and multiples of 4, right? So if x mod 4 I'm trying to think about even numbers as well. So that means that, okay, let's say it's 100. 100, it goes to 50, right? But the last number is 99. 99, 98, so 99 is going to be a 3 in theory, right? Okay, so x mod 2 is equal to 0, then we just choose a even one, right? Okay, let's just say c is equal to x. Okay, and then if c mod 4 is equal to 0, then starts with is equal to 1, else starts is equal to 3. I don't know how I feel about that, but okay. So then now we get the answer for here, and then it is just starts, return starts plus or times 4. Okay, we have to write some base cases maybe. If x is, I don't know, less than 4, return, I'm just lazy, so maybe this will work hopefully. Right, let's give it a spin. Yeah, okay, I mean it's not right at all, but at least it tips me something. It should not be an 8 at all. I mean, it should not be a, this is shocking that there is odd even numbers, and how would I even get 8? So 8, we return 2 numbers, right? We want, so 2 numbers, we want the first number of, oh, and this is, oh, okay. Oh, yeah, right. This should be 0 indexed, that's why. I mean, it's still wrong, but... Oh, 8 is the right number? No, 8 is the input. Why am I'm comparing the input to output. I am just being dumb. Okay. 330, 311, okay. What was it before? I think it was 7, and that's maybe not great. I think the 0 index makes sense, and then we could convert it back to, but that doesn't seem right anyway. I guess this has to be 0 indexed also, actually. And then now we can convert this to 1 index. But this is wrong, right? Because 5 is wrong. Because 5 why though? 5 oh, this is just weird. So everything starts at 2. I meant this as if it's odd, then we subtract it to get even. Otherwise this would never be true, that's why. Okay. But no, I think this is, I mean, it is what I think I want, but I think I want 1 and 3. Maybe? I mean, it works. I'm not gonna lie. I am gonna YOLO it because why not? But I'm not very confident at all. So let's give a quick submit. Okay, got a little bit lucky there, I think, because I probably should have just spent more time thinking about this relationship. But honestly, it wasn't that bad. I just was kind of I don't know, stuff like this just takes a lot of brain power for me. Or like the pattern finding, and today, as I said, I'm a little bit sick or recovering from a cold, so I'm not really 100%. Ironically, the hard one is the one that I don't have a. Thanks for watching, everybody. Hit the like button, hit subscribe button, join me on Discord. Let me know what you think about this contest, these problems, everything in between. Stay good, stay healthy, take your mental health. I'll see you out later and take care. Bye bye.